Hello and welcome back. Alright, today we're going to take a look at strings. Specifically, we're going to be taking a look at C-style strings in C++, how we work with them, and how we avoid some of the common pitfalls that people run into with strings. Alright, so the first thing we need to understand is what a string actually is. Well, if we think about it in a literal sense, it is nothing more than a collection of characters. So if we have the string hello, what it is, it's a collection of the characters H, E, L, L, and O. And so we know already how to represent this if we just think about some of the other data types that we've already learned about. And that is the array. Alright, so that's fine and dandy. Let's go ahead and take a look at what this is going to look like in memory. Okay, so here's our array. Let's put an H in the first block, E, L, L, O, and you notice that I left one more block available. And that is because a special character goes in there. And this is the null character. Basically, this is the 0 value in memory, and it's a \0. So this right here is an escape code. Basically, whenever you see the \/ in a string in C++, this means that this is an escape character, and that the next value right here is going to signify the full escape code. So there's a couple others that we see commonly. There's a \t, which is the tab character, and \n, which is new line. But just a heads up. Alright, so strings are null terminated. And so you might ask the question, well, why are they null terminated? Well, if we think about arrays and how we worked with them, we always had this pointer. We had the place in memory where it starts, and then we always needed to know this other piece of information, the size of the array. Well, we work with strings a lot in our programs, and to be forced to pass around this size all the time is really troublesome. And so to get around that problem, we just always terminate our strings with a specific character so that we can deal with things in our own way. And we don't have to pass in size all the time. It's just easier to work with. And really, that is the basics of C-style strings. So we're going to finish the video on that note. No, just kidding. Let's go ahead and jump over into Xcode and take a look at how we actually work with some of this data. Because there are two major issues that always run up when we deal with strings. The first one is allocating your space. How do you do it? Well, you just define an array like normal. And we can either go in and individually assign each index value in our buffer to one of the values, or we can use some special functions that are already built in for us. And that first one we're going to use is strcpy. Now strcpy uses, takes in two parameters. It takes in the pointer, or the memory address of the place in memory where you want to copy text to. And the second one is a pointer to the string that you want to copy into that location in memory. So if we jump over to our whiteboard, we'll see that, hey, we have an array. I've called it buffer. I've allocated 10 spots for it. One, two, three, four, five. 1, 2, 3, 4, 5. Okay. So here's my buffer. Its size is 10. And right now it's uninitialized. And then I've defined this other string. Oops. Hello. Well, this string, so if we look at memory, we kind of took a basic look at memory. We have the heap. we have the stack. Well, there's also this special spot in memory where all of your literal strings in your program go. And this is usually refers to, as the string table. Okay, so in the string table, we have all of our strings that we defined. In this case, we have hello, so that lives somewhere here, and that actually has a memory address. So if we look at our code, what we're doing right here is we're saying, hey, compiler, pass in the memory address for this literal string hello. And so that's where you get the memory address from there. Okay, so everything looks good here. We have a buffer. It's 10 characters long. Our hello string is only 5. We need to make sure that there's space in this buffer for the null character. So our string that we're really going to deal with is 6 characters long. All is great. You notice that when we type a string, we don't have to actually deal with the null character. It's just handled in the background for us. So let's go ahead and print out this message. Buffer. Run it. Check out our output. Hello. Wonderful. Okay, so that was a 6-character string. What happens if we add more characters? Go to the output, run it. Oh, it looks like everything ran just fine. Well, this is the same problem that we talked about in a previous video, where we had our buffer, and what we did is we wrote to memory that did not belong into our buffer. This is very bad. So how do we fix this problem? Well, in C, there's another function that we can use called strcpy. And so what that does is it acts just like strcpy, except it takes one more parameter. And that is the number of characters that you want to copy. So it's very important that you understand what I just said there. It is the number of characters that you would like to copy from this second string. And since we're dealing with C strings, well, strings in general in C++, we need to make sure that we have enough space for that final null character. So we can't actually copy 10 characters here. What we need to do is copy 9, because our buffer is 10. So we need to leave space for that last guy, and he's the 9th character. So if we run this and see what this looks like, you can see that, oh, we actually only copied the first 9 characters. Perfect. And that is how we can defend ourselves against buffer overflows. Buffer overflows are a source of many, many, many security holes. Because essentially what you can do is you can then write arbitrary instructions in memory and get those instructions executed. And there you have a huge security hole as you have arbitrary code running on your program, or running through your program, which is bad. Okay, so we'll learn how to copy data into a buffer, how to protect ourselves from buffer overloads that way. What about the other way? What if we ask the user for input? So let's go ahead and delete this line. Okay, so let's input a message. What is your name? Okay, we want to read the data. We can just use cn buffer, and then let's print out the output. Hello, buffer. Well, I'll just give you the heads up. cn is not going to do anything for us on protecting us from overloading our buffer. So let's see what happens. Run. Hello, what is my name? My name is David Owens. I sure hope I have 10 characters to write to. Well, my program thinks it does, and it just goes ahead and writes them out. This, not a good thing. So how do we defend ourselves against buffer overruns from user input? Well, there's a special function off of the cin object that we can use. Instead of just blindly writing to our buffer, we can do getline. And we pass in the address of the buffer that we wish to write into, our character array. And then we pass in the number of characters that we wish to receive. And in this case, we're actually going to write 10. because the getline function handles the case where we get the \0, the null character. In the strncpy case, what it did is it blindly copied n number of characters into your buffer. The getline actually does the work for us, so the size for the buffer and the number that we pass into getline is actually the same. So that makes sense. I'll show you an example of what I mean here. Oops. Tried to run it when it was already running. Okay, what is your name? My name is David Owens. Hello, David Owe. Oh. Well, you can see that we've protected ourselves from our buffer overrun. We indeed have 9 characters. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. So we have enough space in our buffer to have that null character at the end. So let's go ahead and look at what happens when we have both of them on the screen. So let's just make another buffer. We will call this stir, and we will give it 10 characters. And we will copy stir and copy buffer stir buffer 9. So remember that 9 for stir and copy, you need the size of the buffer. -1 for getline, you need the size of the buffer. That's just an oddity you're going to have to remember. Annoying, but it's true. So I'll just put hello2 in here, just so we can distinguish between the two better. Separate lines is probably good enough, but if we run it, hello, what is your name? My name is David Owens. You can see that hello2, both of them print the same data. So yeah. So that's the basics of strings. There's a lot more string functions out there. I would suggest that you just go ahead and look at those that you're going to need to be working with. One of them is concatenating strings. That's the strcat, where basically you can take 2 strings and combine them together into a single string. There's also searching between strings, but for this video, I think I accomplished what we want. We need to make sure that we always protect ourselves from buffer overflows. So we should always be using stir and copy, unless you are more than 100% sure that there is no chance in heck that the buffer that you're copying from is bigger than the buffer that you're copying to. You should always use getline when you're getting string data, or any data that you're really assigning to an array. That way you can ensure that your buffer never gets overrun. That's just the most important thing you need to worry about when dealing with strings, not to overflow your buffers. Strings are just arrays, so it's very easy to forget or to do 10 here on the stir and copy, and you end up with no null terminated character. You call another function that expects a null terminated string, and your 10 character string now gets printed out as 400 characters. I've seen it before. I've seen it turn into running arbitrary code, and those are just bad things, and we want to guard ourselves against those kind of things. So those are the 2 easy ways to guard yourselves from that. We learned about how to copy strings, how to print strings, and so yeah. For that, we're going to wrap up this video. Thanks.